This is a question asked in board exam in relations and functions chapter. This is a slightly different question. This is not your regular question because you might have slight changes in finding the one-to-one condition and for on-to condition. We'll see how it goes. We'll first try to see if it is one-to-one. So to start with, one-to-one function. If a function satisfies this condition, that is, if f of x1 is equal to f of x2, then we can conclude that x1 is equal to x2. If this is satisfied for a function, then we can say that it is a one-to-one function. So look at the function itself. So f of x1, that is 4x1 square plus 4x1 minus 5 is equal to, if f of x1 is equal to f of x2, that is 4x2 square plus 4x2 minus 5. We can cancel off the minus 5 and minus 5. We can write this as 4x1 square minus 4x2 square. So that is equal to 4x2 minus 4x1. We can bring maybe all the terms onto the same side. So 4x1 square, we can take 4 as the common term out. So x1 square minus x2 square minus 4x2 plus 4x1 is equal to 0. Or we can say that if 4 is taken common, x1 square minus x2 square can be rewritten as x1 plus x2. And from the next two terms, we can take another 4 common. And this can be written as 4 into x1 minus x2, that is equal to 0. So if you take 4 common out, and also this x1 minus x2 term common out, so you will get x1 plus x2 plus 1 is equal to 0. So x1 plus x2 is equal to 0, and x1 minus x2 is also equal to 0. x1 minus x2 is equal to 0, and x1 plus x2 plus 1 is equal to 0. Now look at this condition. X1 is equal to x2, and here it will be x1 plus x2 is equal to minus 1. Now we'll have to check the function's domain that is given. So if it is given as r, that function is defined from r to minus 5 to infinity. So in this case, if it is defined from r, then this means x can take any real number. X can take any real number. X can take any real number. So which means x1 equal to x2, that is, this is one of the inputs, and x1 plus x2 is equal to minus 1. These two are one of the inputs. X1 is equal to x2, that is acceptable. But if it is also x1 is not equal to x2, as in this case, then we can conclude that it is not one-to-one function. It is not one-to-one function. Because there are two possibilities. One is x1 is equal to x2, which means two inputs, if they are equal, then it results in the same output. And even if the two inputs are not equal themselves, like in this case, x1 plus x2 is equal to minus 1, even then you will get the same output as the result. So which means this is not a case of one-to-one function, especially if the domain reads as just real numbers. If the domain is f r plus 2, this will be minus 5 to infinity. This is minus 5 to infinity. In that case, if the function is from r plus 2 minus 5 to infinity, in this case, the x values can only be positive. X values can only be positive, or it can also be 0. It can only be positive. In that case, x1 minus x2 is the only possibility. Why is that so? X1 minus x2 is equal to 0. But we can also say x1 plus x2 plus 1 cannot be equal to 0. Why is this so? Because two numbers which are already positive or which are already 0, two numbers which are already positive added along with another positive number can never become 0. So this has to be a negative number. In this case, it is very well possible. In this case, when x1 and x2 are real numbers, x1 plus x2 can very well be equal to -1. But in this case, x1 plus x2 cannot be -1. So this case is not possible. X1 plus x2 plus 1 cannot be equal to 0. So this is only possible. So in this case, x1 is equal to x2. This is possible only in case where f is defined from r plus 2 5 to infinity, -5 to infinity. Make note of this. So if the function is defined from r to -5 comma infinity, it is not 1 to 1. If it is defined from r to r plus 2 -5 comma infinity, in that case it is definitely 1 to 1. The reason being we don't have other option than x1 equal to x2. In this case, this is not possible. So x1, in this case, there is this possibility ruled out. That is x1 not being equal to x2, that possibility is ruled out. So we only have x1 is equal to x2. So if x1 is equal to x2 is the only possibility at the end of this check for 1 to 1, then we can conclude it is 1 to 1 function. There is this other case of checking for onto. So to check for onto, we need to find the codomain and range and check if codomain is equal to or is a part of the range. So we need to find the codomain as well as the range. Codomain is already given, which is -5 comma infinity. We need to find the range value. So 4x square y is equal to 4x square plus 4x minus 5. This is a quadratic expression, which means we can complete the squares. So if you observe, the first two terms resemble a square plus 2ab. If a square plus 2ab is equal to 4x square plus 4x, then a is equal to 2x, 2ab is equal to 4x. If you substitute in place of a 2x, you will get b is equal to actually 1. B is equal to 1. So we need to add +1 and -1. So why are we doing that? So we are adding 1 and subtracting 1. So these three terms, they add together and become a square term. So I'm clubbing the minus terms, that is negative terms. So 4x square plus 4x plus 1 minus 5 and -1 club together to become -6. So y is equal to some square term. What is that some square term? This is 2x plus 1 the whole square minus 6. The lowest value of any square term, the lowest value of a square term can only be 0, which means the entire lowest value, including -6, will be -6 itself. So the lowest y value can be -6. The highest y value can be anything. As long as this is a square number, it can be largely squared number, which means it can go up to any value close to infinity. So this value can be anyway until infinity. So look at this. What is the range? The range will be -6 comma infinity. -6 comma infinity. So we are going to now check for codomain and range. So I'm going to use the number line method for this. So in the number line, we have minus infinity and plus infinity, and the range starts from -6 onwards. The range starts from -6 onwards. The codomain starts from -5 onwards, -5 onwards. So if you look at all the elements in the codomain, including -5, all elements of the codomain, they will be part of the range also. They are part of the range also. So we can say that codomain is a subset of the range. So if codomain is equal to the range, or if the codomain is a subset of the range, we can call this as an onto function. So this is a case of onto function. So this function satisfies 1 to 1. If it is R plus, then it satisfies 1 to 1 as well as onto function. If it is just R to -5 comma infinity, it is not 1 to 1, it is actually many to 1 function. And remember, if it is both 1 to 1 and onto, then it will become bijective function. I hope this is clear. We'll move on to the next question, which is a similar question. I'm going to change this question slightly. I'm going to make this as R plus. Now we are going to apply the same logic, the same method as the previous question. We are going to check for 1 to 1. Now the method will be if f of x1 is equal to f of x2, then we need x1 is equal to x2, and x1 if it is equal to x2 plus some other value or x2 minus some other value, then they are not equal. Then x1 and x2 are not equal, then it results in a many to one function. Now in this question, 9x1 square plus 6x1 minus 5, if this is equal to 9x2 square plus 6x2 minus 5, and minus 5, they both get cancelled. I'm going to shuffle and bring all the terms together to, onto the left hand side. 9x1 square minus 9x2 square plus 6x1 minus 6x2 is equal to 0. If you take 9 common out, it becomes x1 minus x2 into x1 plus x2. I'm applying the a square minus b square formula, plus 6 into x1 minus x2 is equal to 0. If you take out x1 minus x2, then it becomes 9 times of x1 plus x2 plus 6 into 1. And this is equal to 0. Now again, if you look at this question, I had changed the question to R plus. What does that mean? If there is an x1, an input value, and if there is an x2 value, they can only possibly be positive both. Right? They can only be positive. So if x1 and x2 are both positive, 9x1 plus x2 plus 6, these two are positive values. A positive value added with another positive value can never become 0. So the possibility of this being equated to 0, that is not there at all. So it can only be x1 is equal to x2. x1 is equal to x2. That means this will be an one-to-one function. Hence the function is one-to-one function. So you have to be very careful as to what the domain is. Okay. So if it is R, you have to be very careful. If it is R, then this possibility is very much there, which is 9x1 plus x2. I'll also make a small note here. So 9x1 plus x2 plus 6 can still be equal to 0 when x1 and x2 are both from the real number set and not from the R plus set. So if x1 and x2 belong to the R set, then that means 9x1 plus x2 plus 6 can still be equal to 0. Then it becomes a many to one function. then you have two possibilities, right? One is x1 minus x2 being equal to 0. The other is 9x1 plus x2 plus 6 being equal to 0. Then it becomes a many-to-one function. Okay, so now we'll move on to function. So we are going to approach this question the same way we did for the previous question. The onto check will be finding the range of the function. Finding the range of this function. So this is also a quadratic expression. So this will be f of x is equal to 9x square plus 6x minus 5. We are going to complete the square term. These are a square plus 2ab term, the first two terms. So what we are going to do is we are going to keep aside the minus 5 term, and we are going to add plus b square and subtract b square. So now look at this. A square is equal to 9x square. So a will be equal to 3x. If 2ab is equal to 6x, if 2ab is equal to 6x, 2 into 3x into b is equal to 6x, then this will be b is equal to just 1. So in this case, f of x, I'm going to write this as 9x square plus 6x minus 5. We are not altering the value. We are just adding 1 and subtracting 1. So the function is actually the same. Now f of x is equal to, we can group these three terms together. So that will be 9x square plus 6x plus 1. And this will be minus 6. Now, if you observe, this is a square term. The whole of this is a square term. A plus b whole square. What is a? A is 3x. What is b? B is just 1. So it is 3x plus 1 the whole square. Doesn't matter what type of a term is it inside the brackets. But what actually matters is this is a square term. This is a square term minus 6. So for a square term, the range starts from, so the square term, the lowest value of f of x, what is the lowest value? The lowest value will be just minus 6. The highest value can be anything, because the highest value can be anything as large as infinity, because this is a square term and it is going to get only more and more positive. And any high positive value minus 6 is going to be still highly positive, right? So it can tend from minus, it can start from minus 6 and go all the way until infinity. So this range will be minus 6 comma infinity. I'm going to use the same number line method for this question also. The range starts from minus 6 to infinity. The range starts from minus 6 to infinity. And I'm going to shade the point minus 6 also. The codomain in this question starts at minus 5 comma infinity. So we are going to start from here. So the range is this. In this case, if you observe the codomain starts at minus 5, just like the previous question. So it is codomain is a part of the range, or codomain is a subset of range. So how do we interpret this? Each element of the codomain is a range element. So if each element of codomain is a range element, or if it is an image of some element in the domain, then it becomes an onto function. Hence, it is an onto function. And look at this question. This function is a one-to-one function, as well as it's an onto function. So this function is a bijective function. I hope these two questions were clear.